So today, thank you for coming. And this, I think, is going to be really a great webinar because, well, it'll be great for me, and I hope for you too, because we're going to learn a lot about our history of ESCOs, performance contracting, M&V, with Donald Gilligan. So Donald is, he's been around. Well, of course, he's been around for a long time, but he's been in the industry, I believe, from the 80s on, and he will correct me. And I believe at one point he was the president of an ESCO, which he will also correct me. In fact, I'm not going to say much more except for he's the president of NAESCO right now, and the National Association of ESCOs. And I prefer, and you probably would too, if Don tells us about himself. So go ahead, Donald, why don't you just tell us what you know?
Thank you, John. I think you were a decade late in my biography. I've been in the energy efficiency industry since about 1977. And my background is that I was for a short time a member of the governor's office in New York, helped to set up the energy office there, helped to convert what was then the Atomic and Space Development Authority into NYSERDA, which I think many of you may be familiar with, and then became an entrepreneur and consultant in 1977. I started one of the first generation of energy efficiency companies that provided services to utilities in response to the Carter administration mandate that utilities provide residential energy efficiency programs. We had an ability to deliver these services to utilities, and spent, I don't know, 2+ years doing what I would now consider to be missionary work with the utilities. When we first started talking with them, even though they were under this mandate, they literally believed that you could not do these kinds of programs. You could not do residential energy audits, help the customers implement the retrofits. They thought that was impossible. They also did not believe any of the technology claims about energy efficiency. So if you go back to those days, there were probably 100 different utilities that were running their own tests of the efficacy of attic insulation. So they wouldn't believe that attic insulation that worked in Boston would also work in Memphis or St. Louis. So they built these little test houses and put attic insulation in them and put some heaters in them and did their own tests. And sure enough, they discovered that attic insulation worked. Once they discovered that, then they were able to go ahead with some of these programs. So the initial set of programs was very limited. There would be a vendor. The utilities weren't doing this themselves. They'd hire a vendor to go out and do energy audits of customers' homes. And I think by today's standards, the energy audits that we were doing were pretty rudimentary. There were only a few types of retrofits that we were doing. You could do attic insulation, you could do wall insulation, you could do some weather stripping and air sealing. But these programs actually started before we had technology like the blower doors. So you couldn't really easily diagnose where the air leaks were and figure out how to fill them. You had to use more primitive methods. So basically insulation. And it was also the beginning of what you might consider to be rudimentary monitoring and verification of programs. So these programs were operating, they were operated by utilities, they were operating under regulatory protocols, and the standards for measuring the effectiveness of the programs was something that's almost unbelievable today. So they weren't measuring kilowatt hours saved or kilowatts reduced or anything like that. They were measuring the number of contractors who would attend training programs on insulation. So they had a quota. You know, they were supposed to, for example, train 200 contractors in a year, and they would measure. That was the metric. They would measure the number of energy audits delivered, not whether the customers actually did anything. Things like that. So it was very, very rudimentary start to the industry. Does that give you a going off, jumping off?
That was in the late 1970s, right? Or the mid 70s?
Late 70s, early 80s.
Okay.
The program that it's kind of relevant today, but the utilities were mandated to do energy efficiency, residential energy efficiency programs as a trade-off to allowing the gas industry to deregulate wellhead prices. So at that point in the late 70s, the wellhead price of gas was regulated. The Columbia gas system, which was a major system serving the Midwest, Ohio, and parts of Pennsylvania, literally ran out of gas. There was one of these, what we would call today a polar vortex. We didn't call it that in those days, but the whole area got way below design temperature for buildings because the industrial and commercial customers were curtailed, and a lot of residential buildings just couldn't maintain temperature. They were way below their design temperatures. The gas industry said, well, if you let us deregulate gas at the wellhead, deregulate the price, then we can solve this supply problem.
Oh, right.
The trade-off was, well, okay, if we're going to deregulate the price, then you have to help customers, residential customers, save energy, reduce their energy bills. So that was the origins of the program.
Okay, so then you made a company that worked with utilities doing that. Is that correct? That's how you got started.
Yes.
Okay.
Yes.
And then, but how did you get into performance contracting, or how did it evolve? Because you were around or working in the industry before there was ESPC, I believe. So can you tell us about the beginnings of ESPC, at least from your point of view?
Yes, I think. So I worked in one of these companies that was doing the services for utilities. We set up, we started with multi-state programs or multi-utility programs in Rhode Island. And then we started another one in Massachusetts called Mass Save, that still exists. Another one in Illinois. And then I got out of that company and got into a standalone home energy retrofit company called the Energy Bank. This was in the early 80s. That didn't go well. I did another entrepreneurial gig with a startup company that was making what would be considered today an incredibly primitive home energy control computer. Our claim to fame was that we had a guy on our team who was part of the original group that invented the basic software at Dartmouth. And we could get a simple control algorithm into 8 kilobytes of memory in this box. It was about this big. Yeah. So, and then I did some consulting stuff in the late 80s and really got into the performance contracting business in the early 90s. By that point, it had started. It really started up in the mid 80s with some scattered programs. And
so who do you know who had the first performance contracts, or what? It wasn't just a black and white event. It was probably, it slowly eased in that way, and next thing you know, it's PC.
Well, what happened was that in the 80s, the utilities were running these programs where as I said, the metrics for success were, how many people showed up, not any kind of energy savings. In the 80s, the utility industry ran up against a kind of wall because the cost of new central generating plants, both nuclear plants and coal plants, which is what were being built in those days, became very expensive. And the utility commissions in several states started looking around and saying, well, what else can we do? Is there some way of doing something on the demand side? And they began to look at programs that would, instead of delivering, number of customers who attended webinars or the number of contractors trained, they began to say, okay, can we switch the metric to kilowatt saved, reducing demand so we don't have to build another power plant? And they essentially turned to the set of vendors who were providing services in these in the utility programs. And by then the programs had expanded beyond residential. There was a program for schools and hospitals. There were a couple of other programs like that. So there were engineering firms involved in delivering these programs. And they opened up bidding situations in a number of utilities, saying, if you bring us KW, that would effectively substitute for new generation, we'll buy it. And the initial offers were really that they would buy it for more than the cost that it would take to assemble and deliver the savings. And there were programs that operated in New York, Maine, I think in California as well. Very primitive programs, very small. Massachusetts had one as well. Maybe their procurement contracts would be in the range of 25 to 50 megawatts. But what it did is it persuaded some of the engineering firms that had been doing the energy audits to assemble packages of services. They weren't going to get paid for energy audits anymore. They were only going to get paid if they delivered KW. So they had to get the implementation part of the business going, and they had to get the financing part of the business going, because the utility the deal was that the customer really didn't pay anything. But the utility would pay the what became ESCOs only for delivered KW, and oftentimes over time. So the ESCO had to be able to finance the installation of the retrofits and then carry those costs and gradually amortize those costs as the utility paid them for delivered KW and KWH.
There you go.
And that was really the beginning of the ESCO industry.
I did not have a clue. I did not know that the utilities were involved in the beginning. I just thought there was some brilliant salesperson out there that came up with a great idea and just started selling it. Oh.
No, because they couldn't. There was no way. The ESCOs couldn't figure out a way to get. Well, first of all, there weren't ESCOs.
Yeah, right.
And the whole thing was driven by the utilities being willing to pay the full cost of the projects. Plus, I mean, typically a payment might be 105% of the actual cost of the project. So it was kind of no-brainer for the customers, and the target customers in these programs were industrials. So if you went into an industrial customer and did a lighting project, for example, and the customer had a 4,000-hour annual runtime, that was a pretty good deal. A lot different from a school building where you might have 1,200 or 1,500 annual run hours. So the targets were industrial customers. The technologies were pretty limited, and the utilities were paying the full cost.
So then your company was just doing utility programs and then slowly transitioned over into PC. Is that what happened?
No, our company did not. Our company stayed. The original company I worked with stayed in the utility services business.
Okay. So you started a new company.
Yeah, in the 90s, early 90s, I started a small ESCO because by that point the ESCO business was really beginning to grow, and that seemed to be a good opportunity.
And have we heard of that ESCO, or has anyone heard of it? I don't know the name of your ESCO. What was it?
It was called Coneco, CONECO.
Okay.
We ran it for a few years and sold it to Boston Edison.
Okay.
Who kept it going for a couple of years and then terminated the business because they didn't really like it.
Right. Because there was a point. There was a point in the 90s when the utilities were buying up, were starting their own ESCOs, and all the utilities seemed to have ESCOs at one point, and that's probably when they bought yours. Is that right?
Yeah, when the electricity supply industry began to be deregulated, there was a theory that swept through the utility industry that a utility had to provide customers with what they called a bundled offering. So you had to be able to offer the customer a bundle of commodity supply plus services. And so at one point there were probably 50 or so utility-owned ESCOs, and that was a combination of utilities buying the first generation of entrepreneurial ESCOs or utilities starting ESCOs internally.
Yeah, there's like Solutions, PG&E Energy Services, FPL, Florida Power and Light had one, I know.
There were literally about 50 of them, and today there are about 5.
Yeah.
Because what happened is that the utilities decided that they didn't really like a unregulated competitive business. They weren't used to it.
And there's risk too, right? They're used to.
There was a risk, and their whole management philosophy was not geared to this.
Absolutely not. Yeah, they have a guaranteed rate of return. They know they'll always make money. With an ESCO, you don't.
My favorite example of the mismatch was one of the small New York utilities started an ESCO. And when they started, they put the managers of this ESCO on the same bonus plan that the utility executives were on.
Right.
And the bonus plan for a utility was linked to increases in return on equity. Well, if you're in the utility business and you can move the return on equity, 0.2 or 0.3 of a point, you get a big bonus. Well, the base, I can't remember, but let's say the base return on equity for the utility company was, say, 9.5%. The first year, the ESCO had a return on equity of about 40%. So the utility executives looked at that and said, well, we're going to cancel that part of the bonus plan. But that was just an example of the mismatch.
Yeah, totally different business.
Yeah.
So you were involved in the beginning, or not involved, but you were active when the NEMVP came out. That was the precursor to the IPMVP. Can you explain why that came out and who made it happen?
Well, from my perspective, and I think other people looking at it from different angles had a different perspective, but from my perspective, the issue was that the ESCO industry was growing. And at that point, ESCOs were financing the projects themselves. Mm-hmm. All of the contracts were shared savings contracts, which required the ESCOs to put up their own money. And it was a very profitable business. The effective financing rate in many of these contracts was in the high teens, low 20s. So the business, and there were a couple of companies that were subsidiaries of small utilities. There was one in Massachusetts called Cogenics, where the ESCO business actually contributed about 25% of the earnings of the utility on an annual basis because the financing was so profitable.
Right.
So that business kind of went along until it grew to the point that the owners of the ESCOs were no longer willing to finance the projects because if you're doing a shared savings deal, you get paid over time based on the savings, which means that you have to carry a liability on your balance sheet.
That's right.
Because you've invested X dollars into the retrofits, you're going to get paid back over time. So you had to carry a liability. And the boards of directors of these companies began to see these ballooning liabilities coming from the ESCOs. Mm-hmm. And this was not only true of the utility-owned ESCOs or the smaller ESCOs, but it was also true of the bigger companies, the service companies, which were getting into the business. So Honeywell, Johnson Controls, people like that, who, they saw this, the entrepreneurial companies, the entrepreneurial ESCOs beginning to deliver these projects. And they looked at it and they said, well, wait a second. We got tens of thousands of existing customers, for our equipment and services. But we should be in this business too. So they began to do that, to begin to offer ESCO type services. And again, their boards saw this same issue, these ballooning liabilities on the balance sheets. And they said, we really don't want to do this anymore. We got to have some other way of financing these projects. At the same time, the banks and other financing people looked at the business and said, 20% interest rates.
Yeah, right. We want that.
We can do better than that. And So they, they began to nose around the business and began to think it was a pretty attractive business. But the barrier was, how do you know that these projects are actually producing savings?
Right.
And, the initial ESCOs that were talking to the banks said, well, we got Fred over here and he's got this great spreadsheet. And, you put a bank loan officer together with Fred, and it was not a good, match. And
I've seen some of those spreadsheets, because that's when I started, was in the early or mid 90s, I guess, and they were laughable. They were some of them were so awful. It was laughable.
Well, but even if they were good, they were not replicable.
Yeah.
Because the guy in the next cubicle had his own spreadsheet. It wasn't the same spreadsheet.
That's right.
And it wasn't anything that could convince a bank to get into the business. And that, it was also driven by the feds, who at that point, in the early 90s, the federal government began to do ESCO projects, and their projects were a version of shared savings. And they were bigger projects, longer paybacks. And again, the issue was, how do you raise the money to do this, and how do you convince the banks and other financial institutions that this is a real business?
Yeah.
And so I think that was, from our perspective, that was the beginning of what grew into the IPMVP. I think there was, a collaboration with US DOE, ASHRAE, NAESCO.
NAESCO was around back then.
Oh yeah. Yeah, NAESCO's been around for 35 years. So we started in the early 80s.
Oh, crazy. Okay. Before performance contracting.
Well, at the beginning of performance contracting.
Okay.
There were,
the beginning had nothing to do with performance contracting. It was just, these are energy service companies, and then performance contracting kind of grew and became the main part of it.
Yeah, what we know today as performance contracting was not what was being delivered.
I didn't know that.
So there was, the beginning of IPMVP with collaboration among a number of parties that had an interest in developing a reliable system to make this a real resource. And then that was the beginning of the IPMVP. And as that's grown over the years. For now on the fourth generation of the system. But that was really a breakthrough, and that allowed the ESCO business to develop a new financing approach, which really let the industry take off. So instead of shared savings contracts, the industry developed what we now call guaranteed savings contracts, which were, go ahead. A shared savings contract was a two-party, a bilateral contract. So the customer made a contract with the ESCO. The ESCO provided all of turnkey service, the development of the project, the energy audit, and all of the analytic services, the construction management, the long-term operation and maintenance of the improvements, and the financing. It was all a package.
Right.
And it was an expensive package.
Sure.
As the industry became more competitive, people started looking at it and saying, well, how can we pull this apart, make it less expensive, grow the market? So one of the ways of doing it was to get the third-party financiers into the business who could offer lower financing costs. But they needed a couple of things. They needed, first of all, a reliable way to estimate the savings to make sure that the projects they were getting into were real. And there were some issues in the projects in the 80s where, things weren't real. There was, you go back, there was a company called Time Energy, which at one point had, had a portfolio of something like 100 projects. And a friend of mine, and they were being financed, they had investors, and a friend of mine was called in to look at this pile of projects that they had to see which ones were actually which ones were actually meeting their contractual obligations and which ones weren't. That was quite a bit of work to figure that out. Anyway, so as the entrepreneurs began to pull these services apart, and the third-party financiers, banks and others, began to be attracted by the business, they needed a reliable way to project the savings, to monitor the savings, and they needed a reliable counterparty to the financing. So again, if you go back to the shared savings deal, from a financial standpoint, the ESCO was taking both the technical risk that the retrofits would actually work, and the credit risk that the customer, if the retrofits worked and the savings were delivered, the customer was good for the payments. That was a lot of risk. So a guaranteed savings project pulls those risk elements apart. The ESCO is responsible, if you will, for the technical part of the project. The retrofits have to work. You have to be able to monitor and verify the savings. The financial institution is taking the credit risk. Is this a good customer? Are they going to pay? Well, that meant that the best customers were government customers. Because they're going to be there for a long time.
That's right.
It's a lot more reliable than a lot more reliable credit risk than almost any commercial customer or industrial customer that you can think of.
So that's why the ESCO business mostly was doing the mush market then. Is that why?
Yep.
Easy.
You steer towards the mush market because those were the reliable credit risks.
I just thought that those were the only people who really wanted performance contracting. I didn't know it was had anything to do with credit.
Well, there was a combination of things. I mean, yes, there is the credit risk was much more attractive in government customers, and the government customers did want the kind of projects that the ESCOs were selling, comprehensive, long payback projects. But again, it's a characteristic of the customer. The school's going to be there. They can make a 20-year contract or a 15-year contract.
Yeah.
If you talk to an industrial customer, they were looking for 2-year paybacks.
Sure. Makes sense. They don't know if they're going to be in business in 20 years.
They don't know if they're going to be in business. They don't,
That's right.
It's just not a good fit. They don't want to buy what ESCOs are selling, basically.
So you were, so were you working at an ESCO in the 80s?
No, not in the 80s.
No, not the 80s, in the 90s when the NEM.
In the early 90s, we started a small ESCO.
That one that got bought. And then did you go to another?
No, I did not. I took, some time off after the sale, and then began gradually to work for NAESCO, initially on a part-time basis, and then and then I've been at NAESCO since early 2000s. I did some work in the late 90s and then in the early 2000s.
So can you tell us, how M&V has evolved, or do you have any insights into that? Anything that's changed? Or if not that, I remember we once attended a meeting with the California PUC together when they were talking about using option C. They call it NMEC, interval data, which was a really awful meeting for me. It was a really interesting meeting. I'm sure it was awful for you as well. But do you have any comments about any of that?
Well, I think from the ESCO perspective, M&V is a tool that we need to make the business work. I think there's there are a lot of people who are interested in M&V from a scientific or academic, what you might loosely call academic perspective. How can we make the M&V systems more accurate, more easier to use, whatever? I think the ESCOs look at it as, what do we need in the way of M&V to make our business work?
Good.
Which effectively means, what do we need to do to satisfy the other players in the business, the finance companies, and the customers, and increasingly the government agencies, which have an interest in the delivery of reliable energy use reductions and the emissions reductions which flow from or a byproduct of the energy use reductions. And so for the ESCOs, it's really a trial and error process of how you get to something which satisfies a customer, and then hopefully a set of customers. You don't want to be doing this stuff constantly on a one-off basis, so that's the basic perspective. The other thing which has gone on and is really accelerating now is the types of measures which are included in ESCO projects. So if we go back to the beginning, we were talking about lighting.
Lighting.
And there weren't even any lighting controls at that point.
Okay.
That weren't worth much. At one point there was a break where ESCOs began to be able to do chiller and boiler replacements. So we were getting into the whole HVAC world. That was the beginning of the business of really lighting. And then in the 90s, more HVAC and chiller and boiler work. A little bit of envelope work around the edges in areas where the energy prices were very high.
And we had the controls.
But as
mid-90s.
And then the controls in the 90s, when the control companies began to see this as an opportunity to push their controls into these projects. But for a while, it was a pretty static set of offerings, set of measures. And then I think what we've seen over the last decade, probably a little bit more, is the range of offerings really exploding. So first of all, you have in some areas distributed generation became a viable option, in which you follow that stream, then you're into renewables, customer-sited renewables.
Mm-hmm.
Well, and now we're into microgrids and demand response. ESCO's, I did a project for the California Utility Commission, I guess it was the Utility Commission in the early 2000s. And they wanted to know why ESCOs weren't in the demand response business. They had all these demand response programs, and they had a lot of demand response programs. I had a slide at one point that showed that there were like a dozen different demand response programs. So part of the problem, of course, was that there was this bewildering array of offerings. But the other part of it was that the ESCOs looked at that business and said, it's a nothing business. It adds a little bit to, the value of a project for some customers, but
Not a lot.
it's not anything we're going to concentrate on.
Right.
Well, that's, I think, now changing pretty significantly. So there's now a whole, then we added water and water improvements, which, are not only toilets and faucets, but irrigation systems, gray water systems in big public schools. So there's an increasing array of measures, only some of which actually generate energy savings that fit into the IPMVP way of measuring a project. So there are measures which the customers really need, which they really want, but don't pencil out, if you will, from a savings standpoint.
Right.
So there's energy savings, and then as the business has grown, it's increasingly obvious that for many customers, the operations and maintenance savings are a huge percentage of what a project can save. And that is another whole set of, how do you measure that? How do you verify that? How do you deal with the variables in that business? And then the increasing importance of, I don't know what to call them exactly, value streams that are not really confined to the building that you're working on. So what the value stream of load reduction is a value stream. Emissions reduction is a value stream.
Okay.
Some of which are beginning to be monetized,
right? But
in general, they're not monetized today. And as we're beginning to learn, the calculation of those savings, the calculation of those values is increasingly complex. So I'm in Texas for a couple of days this week. What is the value of a megawatt reduction in Texas today? What is going to be the value of that in a couple of years? In a system that is dramatic, the supply situation is dramatically changing. The load shapes are, all of that. Well, how do you, in an ESCO project, the value proposition is pretty simple. You get so much savings that the project produces. That savings buys you, if you finance that savings over time, it buys you so much in a package of retrofits. If we know that there's value, that there's savings, but we can't monetize them today, we can't really, say, okay, over 10 years, this is going to be worth, $100.
No idea, but it could be worth a lot.
It could be worth a lot, or it could be worth nothing.
That's right.
And so right now, it's effectively worth nothing in most cases, even though the customers really want it. The customers really wanted, some things. So the ESCOs are really trying to respond to those customer demands and customer needs. But it's a very tricky situation.
All right, that was good. That was good. Do you have? We're running near the end. Do you have? Most of the people here are M&V people, and they work for ESCOs. That's most, not all.
Mm-hmm.
Do you have anything that you would think that you'd like to say? I mean, if they were going to listen to you, and I think they are because they're still here. So, what would you say to them?
Well, I think that for M&V professionals, if you will, I don't know whether that's the right description.
That's a good word.
Good. There's a tremendous amount of opportunity here to define some of these values that we've been gasbagging about for the last few minutes, and to make them reliable. So the ultimate test of all of this stuff is not whether you can come up with an elegant calculation which can stand up to peer review. The ultimate test is, will somebody finance this? Will somebody lend you $100 based on this analysis or this protocol, whatever you want to call it? That's the way the business expands, and that's the way we get some of the demand side savings that we've all been talking about. We've got to be able to gradually extend the reliability of the systems, the predictability of the systems, so that somebody will finance them. And in some ways, the influx of federal money, I think, is both there's good news and bad news. So the good news is it's going to buy a lot of demand reduction and energy efficiency. The bad news is it may delay the development of the longer term solutions. If you can pay cash for a retrofit, you don't have to worry about whether the long-term M&V and all of those analyses are valid. You pay cash on the barrel, you're done. So it's a trade-off. I think what we're hoping is that to the maximum extent possible, the ESCOs use the cash not to buy stuff for cash, but as leverage. So you take $20 worth of a federal grant and you leverage it up to $100, because even all of the amount of the Fed's money that you're looking at doesn't come close to meeting the needs of the buildings. I mean, we're talking about hundreds of billions of dollars worth of retrofits required in buildings. So the question is, can we leverage that federal money into a longer term system that can deliver predictable value that's financeable, and that satisfies the whole range of customers, if you will. So there's the customer actually owns the building. Then there's the customer at the ISO who's buying or looking for demand reduction. Then there's the customer at the EPA who's looking for emissions reductions. Those are different customers with different needs.
Have you heard the argument that once the ESCOs and everyone else puts everyone on solar, we're going to pretty much put ourselves out of work? I know there's still may be, well, let's say we even electrify everything. Is it possible that the ESCO's future is doomed? It might be 30 years from now after everything is solar, but if we have enough power to do everything, why do they need to save anything? I'm sure you've heard people talk like that.
Yeah, I have. I think it's unrealistic. I live in Massachusetts. Massachusetts has,
right,
probably, on a per capita basis, is spending more on energy efficiency and electrification than any state in the country. The prospects for short-term electrification are very limited. I mean, there's a lot of talk, but we can't cite offshore wind. We can't cite a power line to bring hydropower from Quebec to the Boston area to integrate in the New England grid. It's a lot of talk, but it's not really happening. And what we can do in the short term is efficiency. The more efficiency we can do, the more we reduce the need for any source of power, whether it's wind or solar or, in some areas geothermal. But we really got to get the demand down to a reasonable level in order to make this affordable and practical.
Yeah.
We can't cite transmission lines. It's great. Okay, you can talk about electrification, but if you can't get the wind power from North Dakota to Chicago, it doesn't make any difference.
I have a feeling this electrification, solar, and all that stuff, and wind, in the end, we're going to have more work than ever before. I think it's just things don't pan out. They're not linear. That's just not how history is. And I think it's just going to there's just going to be more opportunity, because now there's more of a problem with instability in the grid and all that stuff, and there's more need than ever to control our loads and use less energy. So,
well, and I think what the ESCOs have developed is the ability to understand and integrate the technologies for a particular customer. So, we've talked a little bit about all of the available technologies. Well, what makes sense for this school district at this time? Well, that's a practical problem, and I think that's where the ESCOs have developed a real mastery that nobody else has at this point.
Good. Well, I think we got to wrap it up. I looked, there weren't many questions, but I thought this was a really good session.
Well, I hope it was interesting to people. And
it was for me. And so I figure if it is for me, it's going to be for a lot of other folks. Because why? Because it just gives so much context to what we're doing. And like, oh, that's where the mush market came from. It's like, stuff like that. It's just, we just accepted it as that's how it is. It's like, well, but there's a history behind it. And that was really good. It was really great. I really appreciate your time.
I'm glad. Great. Thanks for the opportunity.